And this is the mystery item. So the question, I'm not asking for answers now. This is your opportunity to probably see it for the first time, but also ask questions. I'll only answer yes or no, really. No, you don't use it with other tools. I don't know if people on Zoom can hear the room or not.
Is the letter A important?
The letter A isn't particularly significant. It's just a letter. A?
It looks like something went wrong with your printing, to be honest.
Nicholas just said, it looks like something went wrong with my printing. And I can only say yes to that. But it's not that bad. It's tiny. It's less than an inch square. And someone's broken it.
Can you guess who?
It was Paul Wood, just for the record.
Is it a strain gauge?
It used to be something. No, it's not a strain gauge. Someone take that drink from him. So they're just passing it around. Any other questions from Zoom?
I've got a question, but I'm worried it might give away what it is.
That's okay.
Is it used for calibrating?
Sort of. Yeah.
Okay.
Yes, I think I'm going to give that a yes. But calibrating what?
Your settings on your 3D printer.
That's a very good question. So I'm not going to answer that. Any questions from the room?
Does it attach to something?
It doesn't attach to anything, no. No. Well, I suppose it could, but it's not supposed to. Sorry?
It's an Ukadaka booby.
It's an Ukadaka booby. No.
I have no idea what.
I've got no idea what an Ukadaka booby is.
Okay, well, keep that in mind. So we're about to move on, but that's your first site, probably, unless you've signed up to the Geekery newsletter, in which you've seen it earlier on that newsletter. Does anyone have an idea what this is? Its purpose. It is definitely about calibration of a 3D printer, yes. It's what's known as a torture test. So it does things that 3D printing is sort of on the edge of its capabilities to see how well it's calibrated.
So that means if you print that and it looks good, it's a good print.
Yes, you're set up nicely, or your design is appropriately designed for 3D printing in a way. So it's chiefly for calibrating your 3D printer, but it's also kind of good for learning how to design things for 3D printing, because it's good at some things and bad at others. I can't remember what my next slide is, so you can see a number of different features here. So can you see my pointer? Yeah, you can, can't you? So this part here, you can see, because it builds it up from the bottom layer by layer, it builds up the two sides, and then it's got to somehow bridge that gap. So this is testing the how well your setup bridges between the posts. So this is printed without supports, which throws in temporary structures to kind of make the bridge smaller, so it'd be more successful. But you can see on the physical thing, and you can kind of pick it up from here, that it's managed to print on nothing to get that bridge, and it's actually worked quite well.
So if you've got a bad quality printer, would that fail that then?
Yeah, you get all sorts of stringing kind of stuff going on. You can see quite a lot of it on. I'm sorry, Zoom, you won't be able to see that, but you can see the bridging didn't work very well on this. This is a cube kind of. Actually, you can see it up in the top left, the top right, whatever, in the corner.
So this is like one of those things that is impossible to create other than 3D printing.
That's right. That's right. So wrong screen. You can see the stringing kind of falling down because it's a bridge too far. So that's. Could you pass it around over there? And you've got two towers there, and that tests a couple of different things. So this one's just a hollow tube on the right, And the one on the left's got a kind of inverted sphere, hollow, which is a little bit difficult. It's certainly not smooth. Also, it's testing because there's no stringing between those towers, like oozing from the nozzle, which creates little wisps bridging between them. And behind those posts, there are unsupported, angled kind of walls, really. And 45 degrees is generally what the maximum overhang you would design. But on this torture test, it's showing 3 different angles just to see sort of where your calibration starts to fall down and the quality reduces. And there's horizontal and vertical holes you can see there, and a bit of an arch. So there's a bit of bridging and a bit of how smooth is your arch. And then there's the embossed letter. And so you can see the impact of the kind of thickness of the bead of plastic that's being laid down. And you can see perhaps in the corner there's a bit of a void in the A, which isn't a good look. So maybe you want to change your settings to be a bit more finessed in the letter. And this is just one, this is a particularly small and quick to print one.
How long does that take to print then?
That was, I think, about 20 minutes.
Oh, really?
Yeah.
That quick? Wow.
Yeah. So yes, it is a 3D print test, also known as a torture test. And this particular one tests your ability to 3D print holes, bridging, circles, arcs, towers, and overhangs. The next slide shows some other torture tests. So this is where I go. Sometimes I go into massive rabbit holes based on the mystery object. I don't go too far into this one. But the Geekery does do a 3D design, scan and print course, which I'm thinking of repeating now we're out of the lockdown sort of phase. But anyway, just focusing on this, Benchy is a very popular torture test, which does cover quite a few important aspects of 3D printing. But this is like the hello world of the 3D printing scene. So normally, you know, someone's really into 3D printing if they've got thousands of those hanging around. This is a sort of the standard test. Yep.
It would have been printed that way on it.
Yeah.
You managed to
You emboss some text in the bottom of it. Yeah.
And to what extent? Because I don't know much about this, but you print them from is it STL file?
That's a 3D. That's a format of 3D model. So
Right, okay.
you have a 3D model in
Right.
whatever format,
Yeah.
and often you export it into STL. But F3D is an
Oh, okay.
upcoming one. That's a better one because it's got dimensions in it. STL doesn't, so you can have problems there.
To what extent can you use software to validate a model before you print it?
So that's really interesting. There are like 3D print farms out there where you can send a model to be printed, and they have algorithms that check your design to see if it's 3D printable or if there are any issues that you need to create. So there are algorithmic validation kind of routines out there. But most people use things like Fusion 360 or Tinkercad is a really accessible, for kids and upwards, really simple to use modeling tool. But you create a 3D model in whatever way, and then you put it through a program called a slicer, and that, as the name suggests, slices it into the individual layers that get printed, adds support, understands the material you're printing in, so sets temperatures, etc. And then that turns it into G-code, which is what you send to the printer. It moves the nozzle around, extrudes the plastic at the right rate, and all of that kind of stuff. But you can see on this image here a number of different, more complex torture tests. I've got an example in here somewhere. This is the octagram one. Sorry, Zoom, I can't hand it over to you. I'm showing the green octagon-shaped torture test, and that tests things like a pinnacle tower to see how sharp you can print, and stringing really affects those kind of things. And there's embossed text. There's dimensional accuracy. So the torch test prints a feature that should be like 10 millimeters long, so you can measure it to see how accurate it is. And lots of overhangs, as you can see from those examples. So, you know, there's a number of things that 3D printing finds difficult and things that you should avoid in your design. But these torch tests gives you the chance to see how your printer performs, and then you can use that to feed back into your designs if you're going to print on that printer. So a useful thing. And the colourful tower there in the bottom right is a temperature testing tower. So at the bottom, it starts off at a higher temperature than it finishes off at the top. So the material, the filament that you use comes into play when you're printing as well. And so there are torture tests where the G code alters the temperature that the plastic's extruded as you go. So you can compare, you know, so you can find out what temperature works with your printer and a particular reel of filament to get super tuned results.